Hi everybody, today we're going to take a look at binary numbers. Binary numbers are made up of only two digits, 0 and 1. Often in computers, 1 means that something is true or on. 0 then stands for false or off. For example, if we had one switch, then it can either be off, which we would write as 0, or on, and we would write that as 1. What happens if we add a second switch? Well, now we could have off, 0, 0. We could have off-on, 0, 1. We could have on-off, 1, 0, or on-on, which is 1, 1. Notice that every time we add a switch, we have two new possibilities. With one switch, we have two choices. With two switches, we have four choices. Three switches would have 2 times 2 times 2, which is 8 possibilities. It looks like this. We could have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, or 1, 1, 1. These values represent binary numbers, but we can also write them in base 10. 0, 0, 0 is still 0, 0, 0, 1 is 1, 0, 1, 0 is 2, 0, 1, 1 is 3, 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 0 is 6, and 1, 1, 1 is 7. Let's break down how this works. Starting from the right, we multiply these values by 2 to the 0, which we know is 1. If you take a step to the left, now we have values that are multiplied by 2 to the 1, which is just 2. And then our leftmost column, we will multiply by 2 squared, which is 4. Notice that we multiply by 2 every time we add a new column. Let's look at that a little closer. Let's take this value 101, which I told you is equal to 5. Here's what we're doing. We're multiplying the number in the column by the corresponding power of 2. So we have 1 times 2 squared plus 0 times 2 to the 1 plus 1 times 2 to the 0. You can see that this works out to 4 plus 1, which is 5. Let's take a look at notation to make sure that we can tell the difference between the number 10, which we write as 1, 0, versus the binary number 2, which we also write as 1, 0. We use a subscript to indicate the difference in the base. The number 1, 0 with the subscript of 2 shows that we are in base 2. So let's try writing 1, 1, 0, 1 base 2 in base 10. To start, I'm going to separate the numbers. So I have 1, 1, 0, 1. And I'm going to start on the far right and put in powers of 2. So I'm going to start with 2 to the 0. As I move to the left, I add powers of 2. So I go from 2 to the 0, 2 to the 1, 2 squared, and 2 cubed. Now we're going to multiply our power of 2 times our number. So I'll have 1 times 2 cubed plus 1 times 2 squared plus 0 times 2 to the 1 plus 1 times 2 to the 0. This simplifies to 8 plus 4 plus 0 plus 1, which is 13. Let's try that again. Let's try 1, 0, 1, 0, 1, 0 base 2 into base 10. Again, I'll separate the numbers, and starting to the right, I'll add powers of 2. So I go from 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th. We need to multiply the number times the corresponding power of 2. I have 1 times 2 to the 5th, plus 0 times 2 to the 4th, plus 1 times 2 cubed, plus 0 times 2 squared, plus 1 times 2 to the 1, plus 0 times 2 to the 0. This time, this simplifies to 32 plus 0 plus 8 plus 0 plus 2 plus 0, which adds up to 42. Now, if you're worried that this is hard, don't be. You do this type of math in base 10 every day. Think about if you got a number like 4,728, that really means 4,728, which is 4 times 10 cubed plus 7 times 10 squared plus 2 times 10 to the 1 plus 8 times 10 to the 0. Each number base is really structured the same way. You always start on the right, and every time you add a number on the left, you increase the power of the base.